means re-emitting of light in all directions by the object. That is the scattering. According to the Rayleigh's criterion, the intensity of scattered light I is inversely proportional to the fourth power of lambda. Now, interesting, the lower wavelength of the light scatters here. In case of visible region, violet is having the least wavelength and red is having maximum. So violet, after the violet, the indigo, blue, green, yellow, orange, red. So the wavelength of indigo is more than that, blue is more than that. So like that, as these lower wavelength of these lights are going to scattered, leaving behind only the red, that is the maximum wavelength. So the sky appears reddish. Means red hue is there during in case of evening and the sunrise time, sunset and sunrise. Evening means sunset and sunrise means morning, early morning, dawn. So why the reddish is there? Because of this reason. And we are talking about the scattering. If the more scattered is there, more scattering takes place. So here more scatterer will be there in case of the atmosphere. So scattering continues and the lower wavelength of the light scattered, only leaving behind the red one, and it becomes reddish during the evening and the sunrise, sunset and the sunrise. That is the reason why sky appears reddish during the sunset and sunrise. And it is only for the small scatterer, not the big scatterer, small scatterer, like the size of the small particles, small droplets, etc., small molecules present in the atmosphere, like that. Now this scattering of light through the glue tube, just to see the white light is scattered and ultimately its color changes. Now here the yellowish and ultimately crimson red. That's a beautiful experiment of showing the scattering of light, why the sky appears reddish or crimson during the morning and the evening. Once more, just see, this is the color changes. Ultimately, here the crimson red. Okay, beautiful experiment of showing the scattering of light.